To access a lot of the advanced features behind the digital power products from Intersil, you really want to have individual control and access to all the PN bus commands that set up the monitoring and configuration of those parameters. Now, with the monitoring view, you get basic information that comes back in terms of what you can set up. There is an expert mode that you can go into, which utilizes something we call a command line tool. This gives you the ability to read and write every single PN bus command to the products. To show you how the command line tool works, we're just going to start from a basic power tree that we have with two different rails that are set up. If you access through the file menu at the top and then click command tool, that command tool will come up. Now this is set up per rail, so you have to make sure that you've got the right target selected, which is always shown in the top right. So right now it's set up for the ZO8800 at phase 0. If you want to switch it to the other output, click on the target and let's just move it over to phase 1. The main benefit of the command line tool is the ability to read and write every single PN bus command within the product. Now you can go in at the top here, you can click command and you can type in any command you want to change, such as the output command. The problem is, how do you remember what those PN bus commands are? If you don't want to look through the datasheet, the quick and easy way is click on the search command. This will list every single command that is enabled in the product. So you can look it up by command code, command name, or even command groups. And a group is effectively our logical partitioning behind the different commands. So for instance, if you're looking for something based on temperature, there is a temperature command and you see every single PN bus command that relates into temperature, either an over temperature fault, under temperature fault limits. They'll all be grouped within this one setting. So let's start with something simple like the output voltage command. So I'm going to go back into this command line tool and I'm going to start typing the vout command. The PN bus command is just vout command. So double click on this and it pops up and says I have it set to 1.5 volts, which is a hex command of 3000. Now hex gets a little difficult to look at and read and adjust, so we always have the numerical version. And we can sit there and adjust this to any value you want. So maybe we change it to 2 volts. And you can see right away the hex value appropriately adjusts for the device. And the send command has now highlighted yellow. The importance of this is we've changed it in the GUI, it hasn't communicated to the device. So if we had hardware connected, we could just click send and would write over to the device and adjust the output voltage on the fly. If we want to add a couple of different commands on here, we can keep dropping down boxes by clicking that plus symbol, or conversely using that minus symbol to remove them. And now we can add in as many commands as we want to if we're quickly adjusting between one parameter and another. The other unique benefit of this command line tool is even with complex commands, it allows you to see all the different bit fields that get selected and set up. That way you're not looking through hundreds of pages of documentation trying to understand exactly which bit controls which parameter. So to give you an example of that, let's look at a command such as user config. So if I type in user config and double click on it, you can see there's all these different commands. Instead of looking at the hex code or maybe the binary code for this and understanding which 0 and which 1 do I change, we can look through and quickly see all the different settings. So for instance, what's the minimum duty cycle? Do you want 0.2%? You click on this box and you can see all the different parameters, 0.59, 0.98, or 1.37. You just click on those and the appropriate PN bus command is changed. And you can go through this with every single command to make sure you fine tune in the parameters exactly as you desire. Let's show another feature of the command line tool. Let's say there's a couple of commands that you use every single day and you don't want to keep entering them in. So for instance, in this example, I've used the vout command and maybe the T on delay and T on the rise. So you're trying to individually set the startup times for every single power rail. Instead of typing this in each time, you can actually make your own command set. So you click make command set and let's type it in and say this is startup. This is then saved into the device. So if we come in and we clear this out, you'll see you can replace command set and there's startup already pre-saved. And this will be pre-saved, so every time you start up the GUI, that command set will be there. And clicking on that, you see those 3 commonly used commands instantly appear. This saves a lot of time, especially with repetitive commands when you're trying to debug a new system. At the very end of adjusting all these different parameters, what you want to do is either save this back as a project file for the entire system, or you may want to export it out as a configuration file. A configuration file is a list of all the commands and appropriate settings for that one target device. You can do this by clicking on the file and then Save Configuration File. This will save the file into the path that's indicated on the screen. And we can now go in and edit this with any text editor. Once you save the command file, you can always load it back in if you need to make edits through the command line tool. Or the other method you can do is open it up through a text file. And this is very useful for the purposes of either archiving the configuration file, setting up external programming houses to program the device. So let's take a look exactly what the configuration file looks like. So if we open up the configuration file in the text editor and we look through it, you can see all the different parameters that have been adjusted and set up for the device. So as we walk to the top, you can see at the very beginning is the product information. What was the target rail that was set up and configured? What was the last revision date when you made changes to the configuration file? Toward the bottom are all the different commands that have been changed, such as the output voltage, or maybe it's the output voltage volt limits. The one thing you'll notice right away is in this file, there's only about 8 commands that are shown, but the device has over 100 PMBus commands that can be individually adjusted and set up. The reason for this is the configuration file will only show those commands that are different than the default settings within the product. That way, it's a very quick and easy way to see what things have changed, especially if you're using this from an archive process. Look at each individual command. What you see is the PMBus command name, the hex value for what data is going to be written to that command, and then on the right, after the comment, is kind of a numerical value. It gives a more user-friendly way of reading it. For instance, vout command is set to hex value 4000, but that really corresponds to 2-volt output voltage setting. What we've just shown is the versatility and power of the command line tool to set up and adjust every single one of the PMBus commands within the product. That way you configure it to exactly the personality that you would like to see. For more information on how to use the PowerNavigator GUI, please continue watching the remaining videos.